and go through this lab.
Thank you, Olivia. 1 second, I'll just take over the screen.
Sure.
Okay, everyone can see that okay? Fantastic. And just a last check-in, if you are stuck, please reach out. Don't worry, we can slow down, we can speed up. So you're ready for your first lap. You've done a warm-up run and we're raring to go. Fantastic. And let's move forward. Lap 1, shift left. As we move forward developing, it's important to see how GitLab uses shift left. We want to make sure that we can catch all our mistakes earlier rather than later. We want to make, if we've got any issues, we want to catch them before they enter our main code line, before they're deployed, and before they are exploited in production, perhaps. So shifting left is a major mindset, or sort of definitely a technique for DevOps. We're going to review the code that enables security scans and create a merge request to bring them into main. So in this lab, we're going to demonstrate and exercise a shifting left. Now, for those of you maybe still new to shifting left or the idea, here is just a small real world example, just to help the concept sink in a bit better, perhaps. So imagine that you're on your summer holiday. I'm actually a dad with 2 younger children, and I've spent many hours building fantastic creations on the water's edge. And you've built your fantastic castle, only to realize that the tide is coming and the waves are catching up, and your hard work is destroyed in a matter of moments because the water has washed over there. If only I had thought ahead and planned on moving maybe the castle up the beach a bit, or maybe we could have put some walls up to defend the structure. But the point here is, if we had shifted left with our thinking and just planned ahead or thought earlier, we could have put steps in place to prevent problems later. So the goal of shifting left is to find and address potential problems earlier rather than facing the consequences later. And we know GitLab do a yearly developer survey. You can have a look at that survey. The QR code is at the bottom there. And we should be able to pop the link into the chat. Don't get too distracted though. We can come back to that after the course, of course. But what we're seeing at the moment is that 74% of security professionals are indicating that they have either or plan to shift left with their security posture within the next 3 years. It's huge. The industry is moving in this direction, and GitLab is addressing that and providing these features on our product. It's also an interesting statistic that's popped up that compared to 2022, where we saw 53% of vulnerabilities being found at the developer stage, so early on in the software cycle, now we're seeing in 2023, that's gone up to 71%. This is a big number. And for us, that demonstrates the importance of shifting left. We're able to pick up those issues a lot earlier than having it causing headaches later on. GitLab is a DevSecOps platform, and it's uniquely positioned. The product has embedded security features across the entire lifecycle. Just to quickly talk you through, right through from the developer creating code, they will be developing new features and actually committing work to the product. We are able to analyze new commits for security flaws and findings with static analysis, password detection, and there's a number of things we can do to catch issues straight on. We have the platform facility to help mitigate vulnerabilities. So again, static analysis and scanning can help us understand what vulnerabilities have been made present, if there's anything new, anything old, and also assist our developers addressing them and mitigating them. And then we have our protect. So we can actually, when we have our cloud native deployments, our platform can monitor and search for, actively search for vulnerabilities. Some of you may have seen this slide before. Certainly if you've been in touch with any of our sales personnel, you might have seen the GitLab flow. This is our sort of workflow. The point here is to talk how GitLab is utilizing AI. We're leveraging AI at various points across the software delivery lifecycle. Right from the very beginning here, on the left side of the slide, where we would start off with our ideation and creation of tasks, through the development cycle in the center, your CI/CD pipeline, your iterative design and testing, and refinement, right to the point where you are approving and releasing and deploying. We are introducing AI features across the board. So do take a look at the AI features. And there's lots of great information on our website about this. Okay. Let's move on to the workshop. I'm going to be walking through the workshop with you. We're going to be splitting up. Olivia will do some of the sections and I'll do some of the sections. But for this lap, I'll be taking care of the shifting work lap shop. You can find the instructions for this, as previously indicated, the shifting left MD. So let's step into that and have a look. What I'm going to do is just duplicate my screen. And what I've got on the screen right now is a look. If I go into my project, I've just recently gone through the steps that Olivia was detailing. I'm also on the demo group as well. I'm in my forked copy of Tanuki Racing Security, and I'm going to go into my courses directory. I'm going to go into my security directory. And here you can see all the laps. And again, you'll get to keep a copy of this after the workshop. You can run through these yourself. I'm going to go into the number 1 shifting left. And inside this markdown file are the details for the lab that we're going to step through. Do reach out on the chat if you're having any issues accessing this. And we can try and get them addressed. Or raise a hand if we need to pause, that's fine. So, first is first. We're going to set up security scanning, and we're going to add those security scanning to our pipeline. I guess it's worth pointing out before we dive into that, this project that you've copied is actually a working demo application. And in here is a Ruby application that is deployable. And we're going to step through, as per the course title, and the introduction is stipulating how to make this application more secure. So going back to the shifting left exercise, the first thing we're going to do is going to add security scans to our pipeline. Let's get to it. Step 1. Let's get ourselves to the pipeline editor. Okay, so on the left pane here, and I'm going to always keep the instructions here on the right just so you can see. On the left pane here, I'm going to go into my GUI. I'm going to click on the sidebar. I'm going to go through to build, and on here we have the pipeline editor. If some of you are familiar with our product or use it self-hosted, you might have noticed as well in recent months that the interface has slightly changed. So this is different from what you used to. Don't worry, it's because we're always improving and iterating with GitLab. You can click on an item to expand the side menu bar, or you can just hover and navigate that way. I'm going to go into the pipeline editor. And you should be presented with the screen similar to mine. The pipeline editor is super useful for building out your CI/CD pipeline. Not only is it giving you the pipeline code, but also highlighting anything that you've included or brought in. We do run a separate course on advanced CI/CD techniques and how to use this. So be sure to keep an eye out for that one if you want to learn more about GitLab CI/CD security. Pipelines. For this session, we're going to talk about security and compliance. So now we got ourselves into the pipeline view. You can see if we look at the pipeline, it doesn't really do very much. What I'm looking at here specifically are the stages. And I can see that there's a build and a test stage. And if you look, we are bringing in our templated testing stage, and we have a defined build stage, which is putting the application into a Docker container. Now, this is very basic. This application doesn't really have anything around it. We need to enhance that. We're going to upgrade. If we look here on the lab information, you can see that we've given you already some CI/CD YAML definitions to predefine how we're going to introduce improved testing to the pipeline. What I'm going to do make sure that I'm in the pipeline editor. I'm on edit mode. I'm going to select all of the text. I'm going to go across to my example, and I would recommend having the side-by-side view here. And at the top right, you should be able to see a copy to clipboard, and that should copy all the example text to clipboard. You can also highlight and copy, depends on where you'd like to do that. Coming in here again, I'm going to Control A, and I'm going to paste in, replace everything here with my new definition. Just to run through that again, we're just going to replace the existing CI/CD pipeline definition with the one that's in the lab. And just to call out exactly what's different here, in this lab exercise, we're bringing on a whole list of additional features and security facilities that will help give us visibility on the application and its security posture. In the original pipeline, we only had the unit testing or the application test itself to validate the functionality. But in this example, we're bringing in the container scanning, code quality, dependency scanning, static analysis, secret detection, infrastructure as code static analysis. We also do fuzz covering of fuzz testing and API fuzz testing as well, which we can talk about later. Once you've gone ahead and done that and paste that, you'll see straight away that the interface is validating the syntax. It's making sure that you've not typed something in there that will break the pipeline. You can also click through to the visualize. I'll stick to the script really. If we look at the include, you can see that we've pulled all these templates. It's really important to see that you can actually see those templates. And if you wish to go and examine them independently, you can do so. If you click on full configuration, that shows you the end result pipeline definition. This is with everything merged together, and this is the entire pipeline code as it is. Please note that you cannot edit this because, of course, it's just the result of the source files, but at least it enables you to get visibility. You can also click on visualize, and on the visualize section, you'll be able to see all the different stages that have been defined and the different jobs that will execute. But if we go back to edit, we now want to commit these changes. So we want to go down to the commit message. We can leave that as update the file. I'd like to be a bit more verbose and give my other developers who I'm collaborating with a little bit of information. But not too much information because that would be too helpful. And we're going to commit that to the main branch. Very simple. So feel free to put in whichever commit message you like. And we're going to go ahead and click commit. Now at this point here, our pipeline is going to start. Okay. And you should see a notification that a pipeline is running. Now, when we ran through the lab setup earlier on with Olivia and we provisioned your demo account, you'll now be using our demo labs runners that will be doing all the work. And usually we find, depending on the workshop sizes, this can take a few minutes or a bit longer, depending on how many people are running the pipeline simultaneously. It's always an interesting, challenging for our infrastructure guys, right? Fantastic. I can come through and click. But however, the GUI, the interface, is already showing me sections of the pipeline that are executing. Let's move on to step 2. The pipeline will take a few minutes to execute, and we're going to come back to that. Now, one of the amazing features, and we use this actually internally quite a lot now, becoming quite dependent upon it, is the Ask GitLab Duo. For example, if you're not quite sure how to find out the status of your pipeline or which pipelines have run, we can actually come in and ask GitLab Duo. You can achieve that by coming onto the sidebar, coming down to the help icon in the very bottom left, and you should see a GitLab Duo chat selection. Please note that all of our AI assisted features will have our GitLab AI Duo icon next to them. By clicking on here, you should enter the Duo chat pane, side pane. And I guess I can just quickly respond directly to a question there. What if you wanted to know more about GitLab CI YAML? We can ask GitLab in plain text exactly what it is we want. And GitLab Duo will process your question and will actually come back, hopefully with a response and some links to the documentation. Our GitLab Duo chat has learnt all of our documentation from the product and is also able to generate examples and links. And yes, don't worry, we are in an AI world. Things are changing. Seems it wants to give us an example. This is quite interesting. Ooh. Just wondering if I'm having a problem with my setup here. Let me ask again one more time. Here we go. Yeah, interesting. I'll try another one. One of the most important things about AI is about prompting and how you ask your questions in the first place, so do pay attention. But again, yeah, here we go. Excellent. And so you can tell already there is a complete reference guide and there's a link where we can find out more. Anyway, feel free to experiment with this feature in the background. Again, you'll have this lab environment for another 48 hours, so you can interact with GitLab Duo. And feel free for the rest of this workshop. We have our lovely helpers in the chat channel as well who can lead you to the right place. But you know, experiment with asking Duo itself any of your questions and let us know if you get any strange answers. So let's come back to our pipeline. And we can see pipeline is executing. And we've already run through quite a lot of the scanning. Important to note here, with all the new included jobs, and again, a lot of the scanners are included with the product. All of the output from these scanners are ingested or read in by our GitLab product, our platform, and they'll be made available a bit later. We'll go through that in a later lap. But GitLab's been busy in the background performing all the additional security scans, which is great. Perfect. We're now going to move on to creating a merge request within the product. I just quick shout out if anyone wants me to slow down a bit, if we're happy. Please call out if it's too fast or too slow. I think we're good. How are we doing, Olivier? Are you happy?
He's nodding. So far so good. Yeah, so far so good. I can follow the steps, so that's okay.
Perfect. So for the next section, I'm going to go over to the code. So back on the side menu, I'm going to go to code. I'm going to navigate down to branches. And here you get a list of Git branches within the product. What we're going to do is we're going to click on, well, I'll tell you what we're going to do. As per the instructions, let's just double check that we are not actually still linked to the original, because remember, we've just forked a copy of the lab. So this is really important. What we can do is we can come back to our sidebar. We can come to settings. We can come to general under settings. This brings us to the general settings page. And if we scroll down and expand the advanced section, you will see here an option to break fork relationship if you have not done so already. You can see that I've done that. This project is now independent of the upstream repository. And yeah, once we've broken that relationship, the original project will remain. It's fine. So let's carry on with step 3 of this part of the workshop. We're going to go to code, and we're going to come to branches. Give me a second. Caught myself out, Olivia. I did not actually miss a step from the instruction. No one called me out. I'm disappointed. We're going to create a new branch, and we're going to call that secure pipeline. And we're going to make sure that that new branch is from the main branch. So if you go to the branches, click on new branch and create yourself a brand new branch called secure pipeline. Here you can see we have the new pipeline. And if you go back down to step 3, we want to create a merge request. Here we can create a new merge request. And again, to create a new merge request, very simple. If you come to code and branches, you should see your new branch. And on the right of the interface, there is a new merge request button. You can click this. You can give it a title. But most importantly, at the very bottom, we need to uncheck the delete source branch. I'm going to give this a, I think we got to uncheck the mark. We can leave it as draft, it's fine. And then we're going to click create merge request. Okay. Fantastic. We come back to the code section again. And we can go into the secure pipeline branch. And just for your benefit, we just created the branch. If we come into the repository itself, you can select any of the other branches from the drop-down here, but we're going to be working on the secure pipeline branch. Okay. And if we come back to the menu and go to the build and pipeline editor, what I want to do here, I'm just going to ask you to put a comment. Okay, the reason we need to do that, because I jumped ahead a step, so we just need to make a non-important change to the file. And I've just added a demo content comment at the top. Just make sure you put a hash and you can commit the change. The reason this is important is because we're making a change on this new branch of the demo. So apologies if I've confused you there, but we're just making a comment, adding a comment to the pipeline. That's fine. And the reason I want to do that is because if I come back now to pipelines, or should I say, I can come back to my merge requests, go into my new merge request that's happening, we can see now that the pipeline is running for this merge request. So what GitLab is allowing us to do is make a branch of the code. We can change the code, and every time we commit changes to that code, it's running our pipelines in that new branch, and we can see what's happening here. So that's running. Fantastic. I'll just take a pause there. If anyone is stuck or lost, please shout. We can step through anything again. We are going to take a short break in a minute while we let the pipelines run. Yep, just to run through that again. I'll step through it really quickly. If you come into your project, go to Build and Pipeline Editor. On the branch at the top here, so at the very top, make sure you've got the secure pipeline selected. So we've got a branch, and this is the pipeline that's executing inside your new secure pipeline branch we just created. And I've just gone ahead and added a demo comment. Yep. And I've just committed that. And when you hit commit, that should start a new pipeline. Okay. Fantastic. And well done. You've completed the first lap. Now it's time to take a bit of a pit stop. We're going to take a 5-minute break. And when we come back, we're going to enter lap 2, which will be about the compliance framework. And my colleague Olivia will be taking over. I'll just put a timer up on the screen, so feel free to go and take a stretch. We've been 50 minutes so far, and thank you for following along. Fantastic. I'll just share on the screen a 5-minute timer. There we go. Cool. See you after the break. All. Feel free to carry on any questions or discussion points in the chat. Speak to you after the break.
Ta-da! Here we are. And let me share my screen. Hopefully, you should all see my screen now. I hope you all have a great coffee, tea, whatever you like. And you're ready to go for the next lap. Maybe I should show the lap. Where is it? Lost. Here it is. Yes. All right. Let's see that big. Okay. So now that we have started to define a new pipeline for security tests, we decided we want all developers to be abide by security best practices. All right. What we are going to do now is to enable a compliance framework to ensure that everybody is doing the same thing and the right things. All right. This is a way to enforce matching some rules, basically an ISO rules, a dedicated avionic rule, whatever, DO 278 for those who know, or ISO 27000, things like that. You can enforce and be sure that you are following the good rules to deliver a product that matches the rules from a compliance that you have to follow. All right. Maybe we can start with a short poll before moving forward. Is anybody having the questions? Can I put them here? I've got the question, but I don't have the. Where is the poll? Is anybody able to help me on my side to push the questions? Nope. Okay, here it is. Thank you very much. So we want to know, how are you feeling so far? Is it too slow, too fast, just right? Or maybe you're lost. Okay, 20 participants. Maybe someone else want to say something. We've got one too fast, a few too slow, and majority think it's the right pace. Then I think we will follow that pace. The two people who are thinking that we're going too fast, please do not hesitate to ask questions in the chat so we can help and have you on track. Okay. And so let's go. Is it working this way? Yes. So as I said, the compliance framework is a way to ensure that you are matching the needs and you are matching the regulations, maybe, or just the constraints from your entity, your main company, or the place where you're gonna deploy your software. Basically, we can see here GDPR. We don't see GDPR. Yeah, we can see here GDPR for anybody deploying a solution in Europe. You must follow GDPR and have this compliance in place. All right. Maybe you are deploying something for the health, then you have to follow the rules of the HIPAA, and so on and so forth with all of these few examples of compliance. We may have many more compliance, and some might be only dedicated to your company. All right, but you want to enforce them while you're developing, because GDPR, for example, is a set of tens of constraints and rules that you must respect. If you do not enforce them while you are developing, then it's a lot harder to comply at the end of your journey, basically when you have finished your development. And it may be too late and cost a lot of money to become compliant at the end of your development and your software development lifecycle. All right. So what are the benefits of the GitLab compliance? The objective here is once again to shift left. We don't want to discover late at the end of the process that we are not compliant and that we have to fix tens, hundreds, thousands of files of code.
I lost your audio, Olivier. I'm not sure if it's only me.
Yeah, it's broken a bit there. And you're back again. Well done.
Hello, can you hear me?
Yeah.
Okay, I don't know where I've been lost.
So I think we missed like a sentence.
Okay.
According to my transcript, it says, "What are the benefits of GitLab compliance?" So basically, at the start of the page.
That slide, basically. Thank you very much, Tony.
No worries.
Sorry about that. Okay, so as I said, the benefit of GitLab compliance is to shift left the compliance to have it as near as the development as it can be. All right, you don't want to discover in 1 month, 2 months, or at the end of your software development lifecycle that you are not compliant with the rules. So basically, and that you have to fix tens, hundreds, thousands of projects. You just want to be sure and know that as soon as you can. All right. So what we are going to do is to enforce that, and it will prevent devs from skipping unnecessary steps. All right. The rules will be applied at the group level or at the project level, and the developers won't be able to skip these tests, okay, or these stages. All right, so let's move on and do that together. We are going to move to the second instruction set, which is compliance framework.markdown, and we'll go through them together. Let me switch to this screen and that one. All right. Security compliance framework. You should see my screen. Let me, okay. I think it's large enough. Please tell me if you can't see things. All right. So we are going to create a compliance framework that will ensure our pipeline runs the correct job in the right order. This ensures no one on the dev team can skip a few tests and introduce a vulnerability. All right, step 1, defining our framework. First, in a new tab, navigate to here to see the compliance framework we intend to apply to our code base. So this is here. I will copy that to the channel, to the chat. So you can just click that if you don't have the material in front of you. Okay, and I will open that here. This is that file. Okay, compliance.gitlab, compliance GitLab ci.yaml. All right, first take a look at the stages section, where each stage defined must be run in order for each pipeline the framework is applied to. Note that the pre and post stages start with a dot. So it doesn't need to be defined to run. What does that mean? We have set here 5 stages, all right? The pre, the post, and in the middle, we are building, testing, and fuzzing. All right, we may not have these stages defined. We may not have any job for these stages. It won't be a problem. Okay, but we are going to use these ones for our compliance, and we will enforce our compliance through these ones. Of course, in your own case for your own compliance framework. You can do whatever you want and define the jobs and the stages that you want. All right. So here we are going to do two very basic things. It won't change anything on the compliance level, but this is for the sake of the demo. We are just going to echo a message at the very beginning, at the very end of our pipelines. All right, without changing anything in our project. We are just going to apply that compliance framework and enforce it for all the projects of our groups. Okay, and then here we are including the individual project configuration. This is the way we do include your own pipeline and leave some liberty, leave the developers free to define their own pipeline while ensuring the compliance. Okay, these things defined here in my compliance framework cannot be overloaded by the developers. Okay, so we have defined, as written here, we have just defined a single compliance framework, compliance job, and a finished job. All right. There is a doc, of course, online to have more details on the compliance framework. So feel free to go there if you want to learn more on the compliance pipelines. What we are going to do now that we know this compliance framework is defined and we know the rules that we want to apply to our product, we're going to apply that framework to our product. So you can now close this tab and navigate back to your workshop project. I'm closing tab and navigate back to my workshop project, which is here. All right. Once here, use the left-hand navigation menu to click on the settings general and scroll down to compliance framework to choose your framework in the drop-down list. I'm gonna open that left navigation bar, go to settings, then general. All right, settings and general. And from there, I will scroll down to the compliance framework section. We will expand it. And in the list, I will choose my framework, my compliance framework. The one that we want to apply here is the Tanuki Racing CF compliance framework. All right. I'm just selecting that one and clicking on change, save changes, sorry. Okay. So from there, what we will see is a new label being applied to my project, saying that this project is now under a compliance framework. Okay. And this is the way that we have applied the compliance framework. And now for the next pipelines that we will run in a few minutes, they will run the pre and post stages that we have just seen. And all the stages in the middle are the ones that have been defined in that GitLab CI YAML file that you have just edited a couple of minutes ago with gems. All right. So what we have seen here is that we have applied a framework to a project to ensure that we are following a set of stages in a defined order, and a set of jobs are enforced and are always run on all projects which are compliant with this framework. Okay. I hope this makes sense for you, because this is a killer feature if you want to ensure you're respecting some rules and you don't want to face the truth very late in your process, being you don't match the expectations, the regulations, or whatever. Okay, it is unclear I can import my framework to this list. The import has been done at the group level. Actually, it has been done for you when we prepared the lab. But basically, this is done. I won't be able to do it because I don't have control over the parent group. But this is done in the settings of your parent group, and you just define what are the different framework that you wanna enable for your projects and subgroups in a parent group. So this is exactly at the same place. If you go to your group, then compliance framework, and here you can enable compliance framework. As I said, I'm not the owner of the parent group, so I can't do this for you. And this is also a way we prevent and we ensure security. It's not open to everybody, of course, so the developers cannot disable the compliance framework, basically. And yes, the compliance framework is available on self-managed as well as the SaaS version of GitLab. So you can enforce these rules and be sure that you respect your compliance framework wherever you are using GitLab. All right, let's move on to the next lab. We have been very fast on that one. So I'm moving to the courses, security, and we'll move on to the third lab, parsing the results. Maybe we've got some more instructions here. Now that our merge request pipeline has completed and we know it works, we want to merge it into the main branch. Let us take a deeper look into the scan and the result of the scan, and we'll create any security policy to prevent any security breach in the future. Okay, I can remember some of you have asked in the chat earlier. We'll see that one. We'll see together how we ensure that it works and why we say it works. But some of you have asked previously in the chat, how do we know that the pipeline works? Are we going to have a look at the pipeline and its results? And this is now, we have introduced that compliance framework in the middle just to leave some time for the pipeline to execute. So let's see that together now. We are going to see a couple of scanners and a couple of results now in the security results of our merge request. And we will see some of them, which are the static analysis, static application security testing, also named SAST, which basically is the scanner which look at your code, analyzes your source code, and find known vulnerabilities in it. Okay, basically this is what we call a white box. So the scanner reads the code and then figure out which vulnerabilities are in it. We also have a dynamic application security testing named DAST, which is the opposite, exactly the black box, which doesn't read the code, but tries to run attacks against your running application. So once you have deployed your application to a temporary environment, this is what we do here at GitLab in these pipelines. We're deploying to a temporary environment, and then we're running attack against this application and see which patterns are succeeding. So we know where we have failures, where we have threats, and we can fix them. We also have the container scanning for any project running on Docker. So basically, we will once again do a white box and analyze the different steps of your Docker file, actually, and see if there are known issues to write a threat. And we also analyze the base image. So we don't only identify threats from what you have written, but also from the source you are based on. We also have that dependency scanning, which scans the project dependencies. So it obviously depends on the language you are using. May it be Node.js and the package log, package JSON, maybe Java, for example, with Maven or Gradle, whatever. We are analyzing the dependencies that you are pulling and see if there are known issues on these dependencies. Okay. We also have the license scanning. The license scanning scans all the components, all your dependencies, and your own license to see if they are compatible with a given policy, or just to list them if you don't have any policies. Okay, this way you know exactly what are the licenses that you are using. And maybe your company don't want you to use some open source licenses. So they will be blocked here, and you know that you have to select another dependency to remove that license. And the last one, which is probably the one that I prefer, the secret detection. We are scanning your source code to see if you are revealing one of your secrets, revealing your password, a passcode, a passphrase, a key to access your cloud provider, AWS key, GCP, whatever. So we are just checking against patterns for all these keys, all these secrets, to see if you are leaking something and you are putting your own assets at risk. We are also obviously looking for GitLab tokens, and we may even revoke them if you have already leaked them. So we know that, and we have done a security scan for a customer recently, and we have identified thousands of secret leaks, just thousands. They have thousands of applications, so this is adapted to the size of the company. But this is something very common actually, because you are working on your side, you are just copying a password somewhere and it's in the log and you're pushing the logs, or it's in your Terraform state and you're committing that. You don't know it, you don't even have seen that, but it's leaked and the hackers know that. So they may find it and reuse your own credentials to use your assets and do whatever they want with it. So this is a really, really important one. So we are continuing on the workflow that James introduced earlier. And in addition to all these scanners that we have just seen, we are bringing with the AI two major features. The first one is generate tests. We all know that we should start with test and then do development. Well, this is the TDD, test-driven development. This is awesome, but unfortunately, not everybody is doing that. Unfortunately, you may have to maintain some legacy code. You may have bought a company with some legacy code which is not respecting the state of the art, actually. And maybe you are lazy and don't want to code your test. And with the AI, we are able, sorry. This is something already available on the SaaS. We are able to generate the test for a given source code. So we will generate your unit test, and then you can improve the code, maintain it, fix it, whatever, without fearing destroying everything, without fearing having side effects and non-side effects. Then we also have the explain this vulnerability. It currently works on any SaaS vulnerability that has been identified within your source code. Okay, and we will go through that later, don't worry. The explain this vulnerability is going beyond what you have seen so far. We do not only provide the CVE identifier of your vulnerability, the short description coming from the NVD, the National Vulnerability Database, or wherever it has been identified. We are going beyond providing you a short description of the vulnerability, but also a way to exploit it, and then a way to fix it. So while you are in the context, you understand the vulnerabilities you are introducing, you understand how it can be exploited and how important it is to fix it, and then you apply that and you fix that. This is an awesome feature, because if you spend time in a security training, 5 days in security training, doing only that, the week after, you will have already forgot 80% of what you have learned. With explain this vulnerability, you are learning and applying what you learn, so you don't forget. This is an awesome feature, really. Then we will talk about policy. We are going to implement some policies. So what are policies? Policies are a way to take actions based either on scan results, these are the scan result policies, or to trigger some action, these are the scan executions. Okay, we may trigger some execution, some pipeline execution. We may trigger some. Sorry, I was reading the the chat. I should leave that on the side. We may trigger some execution scan on a specified schedule, for example. Okay, to be sure that we are checking for security threats regularly every night, for example, on a given project. Keep in mind that you have gone through all the security scans during your development, during your merge request, but there are 0 days threats. There are new vulnerabilities discovered every day. So what you have scanned today may include some new vulnerabilities tomorrow. So it may have, it seems logical to scan regularly your source base. So if new vulnerabilities are added to our database, GitLab advisory database, they are discovered on your code and you do not put your assets, you do not put your customers on threat. Okay, this is what we are going to do together right now. So let's move on to the third instruction, the third lap together. Here we are. Third, parsing the results. All right, I'm just having a look at the chat to check if everybody is on track. Looks like Domi has already answered everything. You're awesome. Thank you very much, Domi. So everybody is following. That sounds great. So first thing first, step 1, merge request security results. We're going to use the left-hand navigation bar to click back in the merge request and then click on the merge request we created earlier. So let's go back. I'm going back to my project. If you're not on your project anymore, just use the breadcrumb here to click on your group and then select your project. And once you're in your project, use the sidebar and go there in the code section and in the merge requests. Oops, I didn't do the job. I haven't followed. Maybe I can switch to your group, James. Otherwise, it will take too long.
No
Can
problem.
you share me your group ID, please?
1 second.
Sorry about that. I was answering on the chat. I didn't realize I have to show this. Well, I know I have to show this. Didn't realize I won't have it. Okay, awesome. Thank you very much.
No problem.
So from there, we've got the merge request. And I will click on that merge request here. And the pipeline is still running. Wow, that's weird.
Because as we move on into the day, the demo environment becomes under more demand, and lots of workshops are running simultaneously. So it could be a little bit slower than normal, but we're almost there on my one at least.
I hope so, and I hope this is the same for everybody. because without the results, I can hardly show you what's happening. Well, we'll leave this pipeline. Give me 1 second. So I will show you that in my own environment. And then we'll go back to your we'll go back to your project if the pipeline is not yet finished. I've dropped it. Tiny key security racing. Do I have?
Mine's just finished.
Yeah, awesome. Okay, and I found mine if needed on my side. Okay.
Mhm.
So what we can see here is that the pipeline has finished. That API further took a little bit longer than expected. So maybe in the chat, you could just say where you are, if the API further has finished for you as well, or if not, and we will take a few moments to wait so everybody can follow the workshop. Okay, if anyone has his pipeline not finished yet, please say it in the chat so I can wait a little bit. Otherwise, I'll move on. Okay. Waiting for my pipeline to finish, David. All right. So let's answer maybe a few questions if there are some questions that are still unanswered. Yes, Devon. If you see 3 green stages, well, actually, if all your stages are green, that means that you are good to go. If I'm going back here to the sidebar, code, merge request, if you see that little green icon here, it means that your pipeline has passed, basically. And so if it has passed, it is finished, obviously. And if you have clicked on your merge request, then you will see here the same icon, the green icon near your pipeline number and all the steps, all the stages of your pipeline here in green. All right, this is the way you know that your pipeline is finished. Okay, so maybe while the pipeline is finishing for David, because the runners are a bit overloaded, we can focus on a very interesting feature here. Well, basically, James introduced you the merge request. He said that every enhancements on your project are living in a merge request. So when you're doing some enhancements to your project, you are putting them in a merge request. They should answer a query from an issue. And here you have that little drop down here, that little section, which generates a summary of what you have done in your merge request. So you can know that this matches your needs from the issue that has been created and the issue you are working on. You have an issue, you create a merge request from that issue, and here you have the summary of what you have done in that merge request. So you know that you are doing the right things. Okay, no worries. Tobias, for the yellow SAST, this is perfectly okay. So the AI has generated for me a quick summary, and I know that I have done the right thing here. And since my pipeline has finished, I have these 3 little widgets which appear here. which are giving me the details and the result of my pipeline. Okay, everything is embedded here directly in my merge request. So as a developer, I know exactly what's going on. The security is bring to me during my workflow while I'm working. I'm pushing my code and I'm viewing the result here, even before I'm merging, even before I'm going forward to the next environments. Okay, so feel free to expand any of these widgets. And for example, I will expand the security one, which is where we can see some changes here. So we can see that there is a new potential vulnerability that has been identified. This is a critical one, okay, detected by the secret detection. And where we say that we have revealed an AWS access token. Yes. Maybe, James, you have closed your merge request, right? The one on the security pipeline.
Quite possibly, yep.
Yeah. Okay. This is why the merge request has a different name, but this is not a problem. Normally, if you have followed the instruction previously, we have created a secure pipeline branch and then a merge request from that branch. So your pipeline, your merge request should be named secure pipeline, and you should see all the steps here, all the stages of your own pipeline. But globally, this should match what we have here, except you may have more vulnerabilities detected and things like this. Maybe your code quality has changed on your size based on what you have done so far. All right. So from this view, we can see exactly where it occurred. If I go back to the instructions, right below the approval section, we can see that our code quality, license compliance, and security scanning templates we included have generated full security reports. This is what we are looking on the left side of my screen. Okay, what is important here is that we are focusing only on the changes that you have introduced in your own commits. Okay, these are not the security, all the security threats existing in your project, but only the one that you are introducing. The code quality is not the code quality, the overall code quality, but only the changes. Same for the license, same for the browser performance, if you are running the browser performance widget, and so on and so forth. All right, so as a developer, you only know and you only see what you are doing wrong and what you must fix before moving forward. Okay. From this view, we can see exactly where it occurred in the code and read up on why it is a risk. After taking a look at this, you can click the comment icon at the bottom to state that we checked it out and are not worried, and click add comment and dismiss. Okay, so here in the security scanning, I will click on one of these security that has been security threat that has been added. That one, I can read all the details here. I know which project, I know which file. Okay, I know the identifier we're talking about, the severity level, and all the things, the tool that has been used to detect the threat, and a full description. All right. Since I'm not worrying about that, I will just click on that little comment icon here. Okay. And say that I don't care. This is James token, since I'm on his project. All right. and I will just add a comment and dismiss. I'm not a very good guy. Sorry about that, James. Okay, are we all okay with that? We are here in the instructions. I have added a comment and dismiss the vulnerability. You can see now here that it has been dismissed. Updated live. Okay, now that we agree that this vulnerability is not a problem anymore, we are going to merge the code. Okay, so we are just going to scroll down here and click on that merge button. All right. So now it will trigger another pipeline. We can see it right here from our merge request view. You can see that a new pipeline has been triggered on the main branch. All right. And now we will have to wait for that pipeline to complete to have some more details in our project. Okay, maybe we can take a short break here because this pipeline should run roughly the same time as the previous one. So if we have had some delay for the API further in the previous merge request, maybe it will take some time as well for this new pipeline. You can click on the pipeline if you want to see it. All right, so I've got EMI pipeline. I've just clicked on it. I can see this is for the main branch. No pipeline is running. If you have merged your merge request, actually, Abdelrahman, no, Mohammed, then your pipeline should start. Are you sure you have merged it? Worst case, sometimes it may happen. We have never seen it, but it may happen. If you go back to the pipelines, you can always trigger one with that run pipeline button. So on your sidebar, just go to the build section, then pipelines. All right, and here in the pipelines, if no pipeline is running on the main branch, feel free to trigger one using the run pipeline button here. Excellent. So everybody should have a pipeline running on the main branch now. All right. Let me add a small timer.
I'll share my screen, Olivia.
Well, I'm on it. I'm on it. No worries.
Okay.
So we'll get back to this. We'll get back in 5 minutes. Feel free to continue asking questions in the chat. We leave some time for the pipeline to run. This is needed because the result of this pipeline will feed the next reports that we wanna look at. Okay. See you in a couple of minutes then.
Cool. I'll just share my screen. And people have a couple of minutes just to unplug for a few seconds. Thank you, Olivia, for running us through the last couple of laps. Just a quick reminder, we do have the chat available. I think there's been a lot of interaction on there, some good questions, stuff happening. A bit ready to dive into the lap number 4.
James.
Yes.
We haven't finished lap 3.
Oh, apologies, Olivia. My brain's already racing ahead on the number of tasks we're doing.
Yes, you're doing too fast.
Yeah, and actually, you know, I mean, it's a big workshop. There's a lot of items to cover. So, Olivia, I'll. Do you like me to hand that back to you then? Yeah, you want to finish?
Yes. Yeah,
cool.
please.
No worries, fella.
Okay, so now that we have, let me hide that. Okay. Well, yeah. Okay. So the pipeline has run, and now we want to see the result. Our main pipeline, as you can see here, has run. All the steps are finished. So once this pipeline is finished, it feeds this vulnerability report, in the secure section. So if you go to the sidebar, secure, then vulnerability report, you will see all the threats that are known on this project. As you can see, this is a lot more than what we have had in our merge request. Okay, this is the vulnerability report, and from there we can filter on the SAST tool here. All right, and we can click on any of these issues detected to have all the details. As you can see, this is very similar to what you have seen previously and dismissed in the merge request. And here is the very interesting part I was talking about during while I was presenting the slides earlier. The explain this vulnerability. All right, if you click on that button here, you will have GitLab Duo Chat generating a detailed information on your vulnerability here for you. This is the explanation, then a way to exploit it, and then a way to fix it. All right. And so this is very, very useful as a developer because you learn as you develop. Very efficient way to learn and remind things. All right. Now, once we have understood all the vulnerabilities and understood everything that we have to fix, okay, we want to prevent some vulnerabilities to occur. So we are going to implement some security policies. All right. We now want to change the filter of severity for severity to critical and change the tool to secret detection. Let's go back to our vulnerability report and see here severity critical. All right, and the tool will be secret detection. All right, we can click any of these, the AWS access token that we have just identified earlier in another file that I've dismissed, for example. Okay, and so we can see that the token has already been leaked. This one has been leaked because it is in the main branch. So anybody can have a copy of that somewhere locally, and your token is on risk. All right. To prevent this from happening in the future, we're now going to set up a new policy that will be applied to all your next merge requests. All right. So what we're gonna do now is go back to the left sidebar and go to the where are we? To the secure policies. So secure policies here, and we are going to click on new policy to create a new policy. From there, what we want to do, what we want to implement is a scan result policy, which is the policy on the left of your screen. Okay, so we will just select that policy. We're going to add a name to that policy. So say secret detection to keep it simple. Okay, and then under the rules section, we want to select security scan in the when drop-down list. So in the rules section, you've got the when drop-down list, and you're just going to select security scan. All right. And we are going to change that all scanners to only the secret detection. Secret detection, and then we are going to change all protected branch to default branch. Here, all protected branch to default branch only. All right. Then under actions, we are going to choose an individual approver. Here, the last section, action, we're going to choose the approver. It might be a role, security, for example, a group, the security team, or an individual. Here, we're going to select an individual, and we'll set it to Logan, for example. So LF Stucker. I'm just selecting Logan here, and he will be the approver for all these threats, meaning that every time that I will have this kind of detection, every time that a secret is detected, it will require an approval from Logan before being merged to main. This prevents you from leaking your access token, access key, whatever. All right, you ensure that there's the process where someone validates the fact that you are leaking a token, or someone validates that you are enabling a security threat, whatever. Okay, this is the way that we ensure we're respecting some rules. And to apply that, we are just clicking on that blue button again, configure with a merge request. This will create a new project for us with all our policies. And here we have to merge that change in our policy project. So the GitLab is checking for us if the merge request can be merged. What you can see here in the breadcrumb is that we have changed the project. We are still in the same group, but we are no longer on the Tanuki Racing Security project, but we are on the Tanuki Racing Security Policy project. Okay, this project is dedicated to all your policies. So this one can be handled by your security team, so they ensure that you respect the rules. All right. And since I agree with my changes, I will just merge them here. So now all the next merge requests will be enforced with this policy. Okay. Before we move on, let's go back to our project. So I've said, you have seen in the breadcrumb, we are in a different project. Let's move back to our group here and select our project. Remember, we have applied the compliance framework, so this is very easy to identify. Okay. So now that we have finished the step 3, let's move on to step 4. Let's take action on our vulnerabilities. Now that we have a protective policy in place, let's go ahead and ensure it works by removing the secrets currently in the code base. From the main page of our project, let's go ahead and click Web IDE in the Edit drop-down list. So I'm here on the main page. if you are not on the main page, in the sidebar, you just need to click the name of your project to go back to the main page. And from here, you can see the button Edit, which is the drop-down actually. If you click on it, you have access to this web ID. Okay, for the sake of the demo, we are doing everything in the browser with the web ID. You can, of course, do the same thing in your own IDE, may it be VS Code, IntelliJ, or whatever. Okay, from here, I will click on the CF sample script EKS YAML, CF sample script EKS YAML. This is a file where I want to introduce a new threat and see if it is discovered and if it is blocked in my merge request. So we will here add a token at the end of the line 6, which is just a description. Okay, I think I can hide that. Yeah, this way. So here I'm gonna update my EKS IAM role name description, and I will just add my AWS key ID.
Olivia, sorry to interrupt. I think it's worth just to take a step back. If we could go back to the web view, it's a question there: which branch are we editing? And I can see there we're on main, but we want to be editing one of the MR branches, right? If I'm not mistaken.
No. When we will commit, we will create the MR.
Oh yeah, sorry, yeah, got it. Yeah,
So,
yeah, sorry.
No,
Yeah,
no,
just to answer your question, Devin, in the background there. Yeah, we will create a new branch when we get a commit. Thank you, Olivia.
Yeah, sorry, I'm not reading the chat anymore because I was too
distracted.
Buggy. Yeah, exactly. Thank you very much. All right. So from the main branch, you click on Edit Web IDE. It will open that web IDE. Then you go to CF sample script, EKS YAML file, and on that file, we will just add the AWS key that we want to protect, actually, or that we want to detect in the merge request. So let's say using AWS key here, this is just my key, and from there, okay, I'm gonna click on the source control button on the left side and add a quick message and commit. So this is the source control button. If you know VS Code, you should find it easily. Otherwise, this is where you see the number of files that have been changed so far. Clicking it, adding a comment, added AWS key, and then I'm clicking on commit. And here I've got a warning message that asks me, do I really want to commit to main branch or do I want to create a new branch? Let's create a new branch from there. Okay, new security issue, whatever the name you give it. Okay, and once you have clicked on that new branch, created new branch, you will see a pop-up in the lower right corner where you can create an MR. Okay, just click that button and it will open that window for you, asking you if you want to create that merge request. And we want to leave everything as is. Just uncheck that delete source branch option and click on that blue button, create merge request. Okay, so as I said, we have committed, created the merge request from the pop-up, which opened that window. We can add a description, we can add whatever we want, but what we want to do here for the demo is to uncheck delete source branch checkbox and then create merge request. Okay, and here we can see that I've got an approval which is required. Requires one approval from secret detection. If I'm unfolding that, I can see that I've got a secret detection which requires an approval from Logan, who will obviously not give it. So here we can see that the merge request is blocked because I don't have all approval. Okay, from there, you are ensuring that you are not leaking secrets, that you are not pushing threats in your production without an approval. This is on the responsibility of Logan now to approve and to say, okay, I agree this secret or this threat may go to production. Okay, we are not blocking you. We are just asking you your approval. Okay, this is a way to ensure that we can push security fix, for example, in production very fast and things like this. We don't want to block things. We just want your approval, and they will be tracked in the audit section. All right, then we have finished that step 4, and I will hand over to James. So he can conduct you through the lab 4 and move on to the end of the race.
Thanks, Olivia. Let me just get things going again. Hopefully you can see my screen. And we've just had a brief break, so we're going to rattle through the next couple of laps. We do have roughly 30 minutes left or so of the session, so we'll see how we get around and finish the race, okay? Cool. Next up, license compliance and software bill of materials. There's been a lot of emphasis on supply chain attacks, and many governments are moving to a situation where they are enforcing via regulations that we are required to supply software bill of materials. We've decided in Tanuki Racing that it's best interest to have these reports ready to go, just in case if we are affected by a breach. Many of us will know, those of us in the software industry or operations or development, will be very aware of large and very public incidents that have occurred. SolarWinds, Log4j, absolutely classic. And what's happening is, and if you're not familiar with this, it's possible for attacks to be inserted into publicly available libraries. This is called a supply chain attack. Log4j had vulnerabilities inside which allowed attackers to expose systems and gain access to areas that shouldn't have been available. The result of these attacks led to the Biden administration creating a new bill of law in the US stipulating the requirements for SBOM and software supply chain evidence for auditing. What's inside an SBOM? SBOM is becoming quite the industry standard. This next exercise will be digging into the generation and exploration of SBOMs. SBOMs themselves will actually detail all the components inside your software by doing a software component analysis. It will examine the licenses, the dependencies, their vulnerabilities, and we present the SBOM in one of the many formats that are available out there, but we present the Cyclone DX format, which is becoming the industry-wide. Cyclone DX is developed by the Open Web Application Security Project, OWASP. I would imagine quite a few people will be familiar with this. So let's move into exercise number 4 or lap 4. I'll go back to sharing my screen. If you just browse through to your Tanuki Racing project here, and I'm just diving back into the courses tab and under security, and we're going to step into exercise number 4. Pretty straightforward. And the first step, we're just going to examine the SBOMs that have been generated as a part of the existing pipeline scans. To do that, all we need to do is head over to our security panel within the project. So let me go into the project. And I can go down to secure. And I can go into dependency list. And you can see already, we're listing our dependency that we've found by scanning the built container that comes out of this project, the artifact. And you can see we're listing quite a few, specifically here. We can actually drill down into each dependency and see the vulnerabilities that have been detected alongside that version of the software. Our poor developers at Tanuki Racing have got a lot of work ahead of them, I think. But you can imagine we've uncovered quite a few issues here, and I'm glad we're finding them now and not later on the wrong way. It's possible to export this list of dependencies as an SBOM in the Cyclone DX format. All we need to do is go to the export button and click it. And it might take a little while to generate. They can be quite sizable, depending on the complexity of your project. But once it's ready, the download will start and you will have a dependencies JSON file. I'm just using Firefox here to expand the file. It's quite large, so it takes a few seconds to render, but this is the Cyclone DX JSON format using a JSON browser. This file could be used in multiple different places. This is your attestation or your evidence of your software supply chain. If you want more information about Cyclone DX, you can pop onto the website. We've put a link here on the issue, inside the text file, sorry. And the Cyclone DX website is really good. I really recommend checking out the guides. If you're new to SBOMs, really interesting information about how they're built, what's inside them, and how they're useful to you. Excellent. Moving on, license and compliance. So we understand that all our various components will have varying licenses. And we may not be wanting to expose some of those licenses. A really good example here is the GPL version 3 license that requires you, if you're selling software with open source components, to open source the software yourself. So, or maybe there's a license that could end up with some legal problems later on when you're trying to sell commercial software. Many of our customers do enjoy setting license policies, and I'm going to show you how to go through that. All we need to do to start configuring license compliance is go through to the secure menu, and we can head over to license compliance tab. Here already, it's giving you a list of detected licenses, and you can see what's there. We can see a number of MIT licenses on 23 or more components within. So maybe there's a decision that the MIT license is no longer suitable for our business practice. Therefore, we would like to put a policy to block any introduction of software components that introduce software that's under this license. To do that, we're going to configure a new security policy. So we're going to come back to our policies. Previously here, we created the security detection, and now we're going to create a new policy. This policy will be a scan result policy. And we're going to call this one deny MIT license. Very simple. I've given it a name. I've given a brief description. Next up, we want to select when. So it's a license scan policy. We're going to leave this to one side. And we're going to stipulate matching license types, and we're going to select MIT. Skipped a step there. We also want to select the status is newly detected and pre-existing. So we set up our license scan. We told it we want the status to be newly detected or existing. We're matching the MIT license. Next up, we want to set up our approver. we're going to have an individual approver, and we'll make that Logan again. He's a busy chap. It's worth noting here, under the hood, our interface is allowing you to define policy as code. This policy is as code, and the actual code is presented here on the right. I'm going to go ahead and add this policy to my security project with a merge request. Okay, and we're ready to merge. I'm going to click merge. Now that policy is active. Now we can go back to our group and back into the project. And what we're going to do is run a new pipeline so the policy can be enforced. I'm just going to demonstrate this. You don't have to follow me. But just to verify the pipeline's running, I can use my secure pipeline branch, and I can trigger a pipeline execution. I'll leave this running in the background. But as you'll see, the pipeline will start up. But most importantly, as we know we have MIT licenses in there, we should see the policy violations occur. And if we come back to secure and license compliance, you can see detected from the last scan, policy violation has occurred. And you can drill down and find out where that's occurred. Okay. Fantastic. And that brings us very briefly around lap number 4. Just pop back to the presentation. Oh, where are you, presentation? There we go. And we move on to lap 5. And here we're going to talk about on-demand scanning, audit events, and additional settings that are available in GitLab. Do reach out on chat if you're stuck. I'm happy to pause for a second. Just wait a few moments to see if people wish to catch up. I think we're good to go. Let's move on with lap 5. So now we've applied our compliance frameworks and policies and scanners. Now it's time to go the extra mile and just double check by using extra facilities. Again, we're seeing here at GitLab, and do take a look at our DevSecOps report and survey that indicate, we are seeing a growing trend. We are seeing next generation software supply attacks far more sophisticated, and therefore we need to adapt to that. And GitLab is paramount to staying ahead of that curve. We're constantly introducing new features and upgrading our existing facilities to ensure that we're one step ahead. One of the really cool features I like, and has helped some of our customers, is we have partnered with a couple of security education vendors. It's one thing to flag the vulnerability, but also we can forward, if a vulnerability is detected, we can forward the developer to training. It's also worth taking note here, as we demonstrated earlier, we have the explain this vulnerability with AI. So if you don't want to do the led training by one of our providers, you can also reference against the AI. But let's dive on into this 5th lap and workshop. I'm going to come back to my workshop screens. And this time I'm going to navigate through the project in courses, security, and the last exercise, on-demand scanning. And we're just going to step through these final 4 steps, demonstrating a few more features here. One really useful feature we have is on-demand scanning. And this is actually the capability to be able to perform dynamic analysis, security testing. For the sake of this workshop, what we're going to do is just run through how that could be set up, but we won't be deploying the application and running the dynamic analysis because that would take a lot of time for us. You may be able to play with this in your own time once the workshop is over. But what I will show you is the outcome results. So just to talk through setting up an on-demand scanning, we can head over to our secure on-demand scans. Just to re-emphasize that again, under secure on-demand scans, we can click on new scan. And here we can start to plumb in some details. On-demand scanning can be scheduled. It can be part of a pipeline. It can be triggered on demand. In this instance, I'm going to set up a daily scan, perhaps. We can call it whatever's meaningful here. We can stipulate which branch we want the scan to run on. So for daily scan, we maybe want to test our main branch. Next, we move down to DAS configuration. And this is the information we need to pile into our DAS scanner so it knows which environments to scan and what it's looking for. We need to set up a scanner profile. We're going to do that by clicking Select Scanner Profile. And we're going to create a new scanner profile. And I'm going to usefully call it new scanner. We can leave these on as standard. Our documentation covers the various aspects of these parameters. But for this one, we're going to just select passive. And I'm going to save the profile. So now I have a new scanner defined. Next, we're going to set up the profile. Site profile is the target for the dynamic scanner. I'm going to give it a name, new site profile. This is the very important aspect here. We're scanning an active website. I need to give a URL. And just for this one, I'm going to use www.example.com/home. We can exclude some URLs. We can also add additional headers. And we can also set up authentication if necessary. But to complete this section, I'm going to click on Save Profile. It's also possible to enable a scanning schedule. I may want to set this up to be a daily thing, or we just make it as an available configuration. Now, as I mentioned at the beginning of this, I'm not going to go ahead and run this scan because what we haven't done in this workshop has performed deployment of the application. That is covered by some other workshops, but for the sake of this workshop, I'm just going to save this scan so it's available. And there we go. Our on-demand scan has been defined. And it's possible to trigger that scan by clicking the button. And it's also possible to go back and change the parameters for the configuration. I will now quickly pop over to one we made earlier. We've got the actual main repository of this application where it has been deployed. I can quickly show you that working. Under environments, we have a production and staging section, and I'm able to go and open, I can open the production one. We keep that one running, and you can see this is the actual application functioning. But if we come back to this project that is actually set up to do dynamic scanning, we can actually have a look at the output. And just as before, our vulnerability dashboard and reporting tool gives us visibility of the output of that scanning results. I can come into my vulnerability report, get my words out, and I can select DAST. And you can see here the outcome of the DAST scanning. And just with other vulnerabilities found in this section, you can drill down and find out more information about these vulnerabilities. Okay, let's move on. I'm now going to go back and start talking about the next step, which will be project audit events. We can find the project audit events. It may be necessary or is necessary to keep track of who is doing what. If we go down to the menu, click on Secure and come on to Audit Events. Here you will find a complete list of activities that have been occurring against this project. And you should identify some of the activities that have been happening. So here you can see the fact that I added the scanners and we changed approvers. That's pretty much it from auditing events. Do check in on our audit doc pages. It is possible to externalize these audit events for other systems for collection. If you have a SIEM environment or you need to forward on events for off-host processing. I'm going to move on to step 3, which will be the extra scanner configuration. So it's possible to manipulate how our scanners are configured. And to do that, we simply only need to go into the sidebar menu under Secure. And if you drop down to Security Configuration, and first off, we're going to have a quick look at the SAST, the Static Application Security Testing Configuration. And if I click on that, you have the possibility to change a couple of parameters. Have a quick look through those. They are covered in our documentation, which is linked at the top here. It may be important that you do not want to statically analyze certain paths on your repository. It may be important which pipeline stage you wish to run on. It's important to note that this interface here, what's happening is it's just updating the actual pipeline. So it's possible to do this as well manually or directly in the actual pipeline definition. And I can quickly show you that. If I come into the project, I can always go to my Git CI YAML file, and I can make some additional changes to override. Here you can see the max search depth has been increased to 12. More information on the SAS scanner and variables are available again in our documentation. The next up, we can change some settings. I'm going to come to the vulnerability report. Sorry, configuration. Yep. So coming into the security configuration, another area I want to show you. And sorry, just before skipping ahead, you can see also it's possible to enable or reconfigure or change other aspects of our security features. And as the product is growing, this is becoming more and more comprehensive. The next bit I'm going to look at is the vulnerability management for security configuration. This is where it is possible to enable the link to some of our partners for security training. So when vulnerabilities have been raised, we can hot link and provide direct access to one of these partners to provide the training material on how to remediate issues. And that's simply by enabling this. If you want to enable more than one, you can obviously select that and select which one actually is your primary. And we will also provide secondary links to the other providers if necessary. Just do note that you may require subscription to some of these providers to access the content that we will link to. Okay, let's move on to the last thing that I'd like to talk about, which is the code owners feature. It's also possible to highlight elements of your project to belong to an actual code owner. And this means that you can allocate specific approval to an individual based on the file path. This is very simple to set up. All we need to do is go into our project. If I bring up the editor, again, I'm going to go to Edit. I'm going to go to my web IDE. Under my web IDE, I'm going to create a new file. I'm going to call it code owners. It's important that it's uppercase, and it's important that it's spelt this way. Again, you can find this in our documentation. The link is in the bottom. And for this example, I'm just going to copy here. And what's important is I'm giving the wildcard, I'm giving a section, I'm giving a wildcard, and I'm using the GitLab ID to identify the person who I wish to identify as the owner. And maybe I can put myself as owner of all YAML files in this project. Next, I want to commit this into main. So I'm going to save that. I'm going to go over to my sidebar source control. And I noticed from some of the discussion in the chat here, some of you are new to this web interface. This is the open source version of Visual Studio, where we have pre-configured plugins and everything suitable to run with GitLab. If you come over to source control, I can now enter a commit message. And I can commit to main. And I'm just going to continue on that. I'm going to push that straight into my main, and then I can go to my project. And you can see now the code owners has been configured. If a new MR is raised against any YAML file, it will require my approval. I'm not going to demonstrate that here because this is my project, and therefore I don't need my own approval. And I think that brings us to the end of this particular section. Were there any questions regarding these elements? Do reach out on the chat channel. And I think that moves us nicely on to the last lap, the transfer project. This is the final lap. I wouldn't recommend you do this just now, but this is something you can do after the webinar. Here we are providing instructions how you can transfer your workshop into your own space. If you have a SaaS account, you can transfer all your hard work today into that. Just to be aware, you will need the ultimate license to play with all the features. If you're transferring your project into a non-licensed area, some of the features may be unavailable or not functional. Do reach out to your sales rep or our team or online if you want to set up a trial or talk to us about using our product. We've set up a file called transfer project. I'll quickly show you that. I come into my Tanuki Racing project. Under courses, there's a transfer project folder. And if I click on transfer markdown file, we can give you the steps on how to transfer. This is very straightforward, just means going into the settings and identifying the destination where you wish to transfer the project to. So conclusion, I think we've successfully run through many of the features available to you on GitLab Ultimate. We've talked about shifting left in compliance frameworks. We've explored all the vulnerability reporting and dashboards. We've looked at SBOMs and license compliant. And we've also set up on-demand scanning. We looked at audits, events, and other things as well. And to close off, we've detailed about transfer of projects. When we shift left, we ensure that you're always scanning your code. One of the major benefits of having the one DevSecOps platform, such as GitLab, is that this is a seamless experience for your developers and teams without having to switch between multiple tools. Moreover, with that complete end-to-end visibility of all the tools, you're able to apply common policies and you're able to have a single view. And we all like happy compliance auditors. Certainly makes my job easier. Fantastic. I think at this point, with only a few minutes left, we'd be happy to take any live questions and answers. I'd be happy to verbalize anything. So please type in the chat or raise Q&A if you have something that we'd like to talk. Just give it a couple of moments. I do appreciate it's been a long session this afternoon. I think we're good. Okay.
James, there's some Q&A in the Q&A. Not sure if you saw that.
Yeah.
Not in the chat, but the other one.
Yep. So Auntie, yeah, any suggestions on how to manage lists of dependencies which need to be manually installed? So on that front, there are a couple of aspects to that. Talking outside of the product, there are ways you can manage how your developers pull dependencies from the internet using dependency proxies, which is something that GitLab is providing. And we'll be expanding upon. What our facility does is prevent those dependencies from entering the final product. Regarding manual installation, again, one of the key aspects of CI/CD is that the build is automated. So we would expect your build to be fully automated and there is no manual steps, okay? I don't know, Auntie, if that answers your question. Feel free to add some more comments if you want to on that. But again, I would look at two parts of the problem here. One, how your developers are bringing new facilities and features into the product. And two, how they're automatically testing it. All right, talking about embedded systems.
Yeah, maybe I can ask to Abderrahman from the Q&A. The question is, could you mention briefly how to use code quality scans to do the lints? Actually, at the beginning of the workshop, we have seen the pipeline editor, and we have included some templates. There is also a template for the code climate, actually, for code quality. So exactly the same way as we included all these scanners, these security scanners, we can include code quality, and then it will create widgets dedicated to code quality, just at the same place as we have seen the security scanners result in your merge request. So from there, from your merge request, you will see how is your code quality evolving, and you can just accept it or deny it and just fix it if you don't allow your code quality to go below a certain level. And then there is another question from Abderrahman.
Yeah.
I was able to reference internal GitLab security project for the usage of Golang lint JSON reports to appear in code quality, but I'm not sure if the main template does everything. I'm not sure I'm understanding correctly you here.
Just thinking as well on that one.
So if you can add some details, I don't want to answer something that does not answer your question, actually.
I guess one aspect here, if you are finding that our default templates are not covering everything, it's possible to make your own. And in our advanced CI/CD workshop, we do cover how to do CI/CD templates and CI/CD components as well. So it's worth checking that out. And Andy, just to come back to your point, we were talking about manual installation of dependencies for embedded development. That's always going to be a challenging aspect where we can't automate. I would just offer the understanding that because our platform is open source, we have very open interfaces and integrate with numerous tools. GitLab as a single DevOps security platform does try to give the best off-the-shelf experience. However, for very specific needs, we usually integrate with other tooling as well. So maybe that's an aspect that could be investigated. And that would be something that you could reach out to people like ourselves, that you have a solution architect for your account, or you can ask a technical member of staff on those points for a more in-depth discussion. And just for others on the call there, one of the challenges with embedded systems, of course, is that you're often testing with actual hardware and not ephemeral containers in the cloud. It's a different ballpark.
Okay, so back to the question from Abdelrahman, who has provided some more details. My question is if this template code quality GitLab CI YAML can be customized. And if yes, I would prefer if we can get the code quality report templates part of the main documentation. So yes, this template, like all other templates, actually can be customized. This is the basics for all our templates. The easiest way to customize them is to update the variables, basically, but you can obviously update the script or whatever you want to update. Basically, when you include a template, you're just including the pieces of YAML file into your main file. Remember, at the beginning of the in the very first step, first lap of this workshop, we have gone through the full configuration of the pipeline in the pipeline editor, and basically your code quality template is included here, so you can overwrite whatever piece of that template you want. And as James said, this is also covered by the Advanced CI/CD workshop, not specifically for Go, but yeah, we show how to customize the templates. So yes, the answer is yes, and you can do that.
I think it's worth commenting, isn't it, Olivier, that there's a lot of fantastic open source projects out there that are coming along as well, and GitLab's always tracking for best of breed and best implementation on those. But yeah, absolutely, quite a few of our customers do find they need to customize. Thank you, Olivier. Yeah, and regarding the workshops, do check our events page. Let me find the link for that. We do publish our GitLab events. You can sign up to our workshop. I'll pop that somewhere into the chat. 1 second. Here we go. And I'll just link that into the chat for you all. And future events covered by other solution architects and members of the teams. Always fun to deliver. Watch this space. Another thing worth mentioning, if you are an existing customer, you could also reach out and talk to your customer success manager or your sales representative and set up private workshops as well, if you have a large organization that needs addressing on that as well. We're always keen to enable.
Abdelrahman has another question. Maybe you have a different answer than me. He would like to know if we have a list of open source projects that use GitLab pipelines, if there is a web page for it. I don't know any, but maybe you will correct me. Do you know any?
Well, I mean, this is an interesting situation because GitLab, essentially, we do host open source projects, and we actually have an open source program. We will offer licensing for free for any open source projects that wish to come on board, and there's a process to sign up. Unlike other platforms that host open source projects, they have their own pipelining tools. And I'll leave that there, I guess.
Yeah.
But do check out our GitLab open source program, and I'll put a link to that as well. Interestingly enough, as an anecdote, I actually submitted an open source program there and had that supported, which has been fantastic. That's another story. Here we go. Link is in the chat there. Cool. Okay. Yeah. Abdelrahman, so I think definitely do look online, do ask the chat GeoBot for examples. It's something we would need to take offline. I mean, best templates and practices is always a tricky question to answer. Best for who? It depends on your situation, your context, what you're trying to achieve. I mean, for sure, there are some great techniques that we can cover to make your management of CI/CD pipelines easier and scalable. However, depending on what your challenges are, then maybe your best practices need to be evolved more locally. Okay. No problem. It's been a real pleasure. Cool. Thank you very much for attending. I'm going to close the session here.
Thank you very much.
Yeah. Any final words?
Yeah. I just wanted to thank everyone for joining. Thanks, Elena and Marcus and Logan for organizing this. Thank you very much. And thank you for your
Absolutely.
job, James.
Thanks, everybody.
Bye.
Bye-bye.